Thank you everyone and welcome from my side. I'm Jonas Pesanti, Head of Printing at IST France.
And welcome, I'm Romain Guillaume, Head of Industry at IST France.
We are both engineers and we have a degree in lights and physics. And today we want to give you an overview of the differences between UV mercury and UV LEDs. We want to help you to find out what is the best solution for your application. First of all, we need to distinguish the component, the technology, UV mercury or UV LED, and the system, mercury or LED. Today, we are going to talk about the differences of the component of the technology. First, just a quick reminder of the UV spectrum. The UV spectrum goes from UVC to UVA. And of course, the first difference between mercury lamps and LEDs is the spectral emission. Mercury lamps only emits 20 to 30% of UV, the rest is visible and infrared, whereas UV LEDs emits a narrow bandwidth at 365, 375, or 405 nanometer. This bandwidth is around 50 nanometer wide. The first consequence is that the chemistry should fit this UV source, and so sometimes it's not possible to get the good photoinitiator which will fit to the UV LED spectrum. Thus, some varnish notably are not available for UV LED. The second main difference is the size. UV LEDs are smaller and you can make custom design. For example, we have shown a handheld system we offer at IST, the Handcur. You can see this system is based on the UV LED technology. It would not be feasible and available in mercury technology. Then, of course, you probably know the lifetime. LEDs last longer than mercury. We have to say also that when UV LEDs are not have not enough power to make the application, then you need to change all UV LEDs, not only the lamps. So the cost is really higher than just changing a lamp, a mercury lamp. Then for maintenance, you have almost no maintenance with UV LEDs. You just have to blow hairs in the filters once a week or twice a week. UV LEDs are instant on and off, whereas mercury lamps, you have to wait the warm up and the cool down. Then the consumption, of course, the UV LEDs consume really less than the mercury lamps. Normally, it's around, for the system, it's around 50 to 70% less consumption for UV LEDs. UV LEDs are less expensive for a narrow system with a length under, let's say, 50 to 60 centimeter. Then for a longer length, they are more expensive than mercury lamps. Normally, if you double the size of the UV LED system, you double the price approximately. The chemistry is more difficult to make, and also photoinitiators of UV LEDs are more expensive, so the chemistry is a little bit more expensive in some cases. And to conclude, also the UV LEDs don't create ozone and don't have mercury, so it's better for the environment and also better for the health of the people.
Okay, thank you, Jonas, for this list, illustrating the differences between these two technologies. Once we have made this, we can think that the job is done. When we ask ourselves what is the best technology between UV mercury and UV LED. This is a question we have almost every time when we discuss with our customers And just looking at this list to propose an answer is not really enough. There is no white or black answer. We can't say that UV LED is the best solution or that mercury lamp is the best solution. To do so, we have to take into account the UV curing application we have in front of us. And once we have this application in mind, we must look at how the difference between UV mercury lamp and UV LED will play and adapt themselves regarding the selected application. And so now I will try to explain you how at ISTMS we approach a UV curing process in order to select and define the best technology. First, we look at the formulation. We look at the chemistry itself, which is in fact the product we want to cure, and so that will react with our UV light. And so a formulation will have a specific needs depending on its components, like photoinitiators, resins, pigments, etc. And these needs can be the following: specific spectrum, spectrum sensitivity, peak power in watt per square centimeter, and also total energy needed, as we can call it, the dose in joule per square centimeter. And so here we already have some factors that will help us selecting the right technology. And then in a second step, we also look at the industrial environment. For example, we consider the size and shape of what we want to cure. It could be a spot, it could be a surface or lines. For example, we won't need the same technology if we have to cure a glue dot in the needle assembly, or if we have to cure a varnish on a PVC flooring. The size and the area are totally different, and so is the technology. Taking this into account, all of this environmental around the industrial application, we reduce our range of technological choice. We also keep in mind the working distance, the space availability in the machine, and of course the speed of production, which is closely linked to the need of power and energy of the chemistry. And last but not least, we have to consider the cost and use of the technology itself. The first two circles were focused on the technical aspects, but we can't forget the economical factor when we deal with the UV curing. In that case, we have two big parts. Firstly, we have the investment cost. Depending on the power and the size of the curing needed, some technology won't really make sense because of the cost difference. Because the cost difference would be too high. For example, when you want to cure a glue spot, it is way more economic and efficient to use a small UV LED component, so the UV LED technology, than a big mercury lamp. Secondly, we have to take also into account the production costs, including the chemistry and the maintenance, which will vary depending on the application. And at the end of that, if we are lucky enough, we have a technological choice that will fit with all the factors taken into account for the specific application. And at ISTMS, if we identify this crossed area between the three circles, we will be able to propose the right technology that will suit perfectly the needs of the selected application. And so this way is the way to illustrate you how we approach a UV curing application. And at the conclusion, I would like to share with you the three main points you should remember from this talk. The point one, the difference between UV mercury and UV LED don't make a real sense if you don't take into account the application process. It's what we explained in the previous slides. The point two, another thing we see a lot of time on the market is that the two technologies are often presented like one against the other. And we think that these two technologies are offering us two ways of solving a UV curing needs. And all the time we have to think about which one will suit the best. And point three, if we keep point one and point two in mind, we can also discover and see that the combination of these two technologies can also bring and open new solutions for the market. So I think we are done. Thanks a lot for your time.
Thank you very much.
Of course, if you have any comments, any remarks, question, or would like to go deeper in this topic, feel free to contact us. We'll be very happy to answer your questions. Thanks again, and
Thank you.
enjoy the next topics.